Good evening, everyone, and welcome back to another episode from the Azure Happy Hour series. My name is Rashmita, and I am the event planner for Microsoft Reactor India. I'm here today joined by our very own host Reshmi and our special guest speaker Shubham. But before we start the session, I would request you all to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat section is open throughout, and we do encourage you all to participate. Our speakers will answer all your questions during the session, so please feel free to drop all your questions in the chat section. With this, thank you all once again for joining us today, and let me bring in Reshmi into the stream to begin the session. Hey, hi Reshmi.
Hi Rashida, thank you for introducing once again. I think I'm slowly by hearting the lines you're saying.
Yes, it's the same. But yeah, it's always pleasure to have you and have our audience back to the Azure Happy Hours. But without any further delay, the floor is all yours. I'll be at the backstage. Thank you.
Thank you so much. Thank you. So, without any further ado, once again, I don't think this really requires any other iterations. But as you all know, we in Happy Hours try to bring the best of whatever we find in Azure, which could be used for your day-to-day projects, which could be used for your enterprise developments, all sorts of things, right? And today we have a very special topic. We are going to talk about Sidecar in Azure App Services. And this is something which you might have heard of late in the big announcements like build and whatnot, right? And we are really developing wider into Azure's app services story with Sidecar. So today we have our very own developer from Azure App Services, Shubham Jain, joining us, and he would be talking about how exactly the Sidecar journey goes with Phi and Quadrant. So Reshmi, a PM in Microsoft Azure. I'm your host, and of course, I am open to addressing all your questions in the chat. So again, let's quickly introduce Shubham. So Shubham, welcome to the show. Welcome to Happy Hours.
Hi, Reshmi. Thank you.
Hi. So for our guests who are probably seeing you for the first time and who would be really curious to know what you do, what is the thing that you're going to talk about, maybe we can do a quick brief of you plus the topic.
So today we'll be talking about the new feature Azure Linux App Services launched. It's in public preview right now, and I am part of that core team which has developed that feature, and I've been part of this team since 3 years. And I think it took us a lot of effort to build that feature and get to the public preview right now. So very excited to talk
Awesome.
about it.
Awesome. This is really exciting. I'm sure like people who are there in the chat and who are like watching it later are going to be equally interested. And I'm going to ask you a quick side question before we dive deeper. How has your experience been in developing this feature? Did you actually enjoy the journey? Is there some great learning you had in this creating this feature?
Yeah, definitely. It was really amazing to develop this feature. And before joining this team, before started building container solutions, I used to work at the other end where I was consuming these solutions. So when I started working on this, I had a lot of ideas which I could implement and which I thought as an application developer which I would need, and I was able to bring those ideas to production with this feature. And yeah, uh, it was amazing.
That is really exciting. My second question before we dive deeper, and I'm so sorry I'm already asking questions. Do we have a ZA date already in mind? Is there something which the audience should be looking for?
So we do have a plan for GA, but the date is not finalized yet, so can't comment on that yet. But rest assured,
Okay, it's a
very
suspense.
soon. Yeah,
That is nice. That is nice.
yeah,
Cool. With that, let's quickly start to the topic. So let's go through your content then.
yeah,
The floor is yours.
yeah. So I'll be discussing about this new feature in Azure Linux App Service. This is in public preview right now, and we will also see how we can leverage this feature to augment our AI native applications. So let's start. So Linux Sidecar feature allows users to run multiple containers in their application. These containers share the same network and same network host and configurable shared mounts. So this lets customers implement sidecar pattern. Before going into this feature much, let's discuss about what is sidecar. So in sidecar pattern, the core functionality and peripheral tasks are abstracted out into different containers. Like you could have your application running in a different container, and then the peripheral tasks like logging or proxy or reverse proxy, front proxy, all these can run in a different container. And the only important thing here is that these containers need a way to interact with each other. So either the network host should be shared, or there should be some shared file system that they can interact with. So, and that's how this sidecar pattern is implemented. For example, you could have an application which is running in a different container, and then you might be using some aftermarket solution like Datadog for metrics and logs, or maybe New Relic, or you might be using Nginx as a reverse proxy to your application, or maybe Dapper as a forward proxy to remote services. And so this lets you have different containers and lets your application be loosely coupled into different components but highly cohesive. So that's sidecar pattern. So in Linux
A
App
quick
Service, we
question here.
share.
Okay, yeah, sorry.
Yeah.
Go ahead. Yeah.
So in Linux App Service, we let the network host on the worker be shared between these containers, so that these containers can talk to each other via local host and port. And users can also configure shared volume mounts between these containers so that the file system is also shared. But yeah, Reshmi, your question.
Yeah, yeah. This is really great. So this is just along the lines of what you just said some time back about these components being loosely coupled, right? So is there like a restriction in the relation being a one-is-to-one kind of connection, or is it possible that one sidecar can be configured with multiple primary applications as well?
So this means that one primary application can have multiple sidecars, but
Okay,
these
that
sidecars will
okay,
actually run in one VM with the application container. So one sidecar
okay.
can only be coupled with one application.
But the other way around is possible.
Yeah.
Got it. Okay, okay, that helps. Yeah.
So if
Sorry,
so,
continue.
yes. Think of like if you have your application running on multiple virtual machines, multiple instances. Each instance will be a collection of containers. One main container where your application is running, and the other sidecars. And each instance
Got
would be replicated like this.
got it, got it. Makes sense. Yeah.
So we'll talk about a particular use case today. It's a very simple, small use case for an AI native application. We want to build a chat application for a company's customer care, and we have few constraints that we have to keep in mind. The responses should be highly accurate. Like if the customer is asking a query, the customer should get an accurate answer, and the chatbot should be highly responsive as well. It should reply in like few seconds or maybe like 10 seconds. And the cost is the biggest factor in AI native applications. The cost incurred in using OpenAI APIs and ChatGPT APIs. This is a big factor when you're designing your AI native applications. And this is another constraint that we have to keep in mind, is that this cost, we have to minimize that. So with these three constraints, we will start building this use case. So let's start with a basic solution. So I can create a web. Let's create a web app which talks to OpenAI API via the OpenAI API. And so whatever the user is prompting, we are as is sending that user prompt to the chat API, the OpenAI API. So this will work. We'll get sufficiently accurate answers, and there'll be a lot of back and forth between the chat API and the user. And this all back and forth, like for example, the user is saying my dashboard is not working. Now this chatbot needs to ask the user like what is not working in the dashboard. The user will say that some part of this dashboard is not working. Then the chatbot will ask like, what was the last action that you did? Some basic level of questions that this chat application will ask, and this all back and forth will be happening with the ChatGPT API also, like the OpenAI API also. And this will incur cost, like every back and forth we're using the API. The latencies will be dependent on how OpenAI API is performing, and the accuracy is moderately. This is moderately accurate because the OpenAPI may not have the most context. So that's the basic solution that we can think of. Let's try to optimize it. Let's see how we will be able to optimize it. So before optimizing it, let's talk about Phi 3 models. So this is a family of small language models. They're highly performant and they can be customized by fine tuning. And the best part of this Phi 3 models is since they are small language models, they can be locally deployed, and you can deploy it on a small instance with a small GPU or no GPU at all on the CPUs also, and you will get highly accurate answers. And to increase the accuracy, you can fine tune these Phi 3 models. And this fine tune, since these are small models, these fine tune are also very efficient, and it is not as equivalent to fine tuning a chat GPT model, which is a large language model. It's uh, way faster, like huge order of times faster than fine tuning a large language model. So what we can do here is we can take a Phi 3 base model, train it, fine tune it on some past customer query related data, which has a lot of back and forth. Like, if this is the query, this is the response. We can fine tune this on top of that data, and we can create this highly customized small Phi 3 model, and then we can run this Phi 3 model as a sidecar in our web app application. So essentially, since we don't need a GPU, this can run on Azure App Service. So let's see how exactly it would be happening. So here we have a main container and a Phi 3 sidecar. This Phi 3 sidecar is the highly customized, highly fine-tuned on the company's data. And so what is happening is when the user is sending a query, like my dashboard is not working, we don't have to send this query to the GPT API at that moment. We can let the Phi 3 sidecar take over and let Phi 3 ask those basic questions, like which functionality of the dashboard is broken. The user says the dashboard is not showing me the billing usage. It can ask you, did you perform any action after it was last working, or what were the steps that you took, and all this type of information, the basic questions Phi 3 can ask. It doesn't have to like give it a solution, but at least it can collate all this information. And once this information is gathered from the user, Phi 3 can also summarize it and prepare a proper prompt, which can be sent to the GPT API. And so this way we have cut down a lot of requests to GPT API, and hence latency and cost optimizations.
So even here, like we are banking on the fact that Phi 3 is able to do a good summarization of the user asks. So we
Yes.
still can't call it like the most efficient, but it's way efficient in terms of like the cost and in terms of the resource consumed for answering the questions, because you're using something which is faster, low latency for confirming with the user, and then you get the summarized prompt, you give the summarized prompt to GPT.
Yeah. So
Interesting.
definitely there's a trade-off. If GPT is doing the first part of collating all the information, definitely it will do a better job than Phi 3, but at a higher cost.
Correct. Got
But if you let Phi 3 do it, it will just be cost optimized. May not be the best job, but in our use case, it might work, because we don't have to give a solution. We just have to gather the information in a natural language chat.
Got it.
So this is how we can use Phi 3 in Sidecar. So something to note here is that let's say this just want to call out how exactly the internals would be working in Azure App Service. So when you create an instance, when you create a web app, let's say you have 3 instances, just reiterating it, every instance would have one main container and one Phi 3 sidecar. So this Phi 3, so sidecar pattern is very powerful when you have a stateless type of application. So here Phi 3 sidecar, this is a stateless. It is not maintaining any state. So it can be linearly scaled with the VMs. Like if you're scaling VMs, each VM will get one Phi 3 sidecar and they don't have to manage any state in between them. So whenever a state is involved, like a database or thing, that may not be the best application for sidecar in some scenarios, but here running Phi 3 in the sidecar is spot on.
Got it. Got it. So it's basically recommended for stateless use cases.
Stateless usage,
It's
yes.
yeah. Got it.
So that's why we would see Redis or Nginx, all these type of applications, all these type of solutions running as sidecar. They're highly performant in a sidecar pattern, or even logging agents. All these are not maintaining any state on the instance.
Correct. Correct. Got it. Yeah. So one more question before we move to the next slide. I'm so sorry. So the second half of it, where we are like reaching out to the chat GPT with the prompt, is that again something which is happening within the same host where we have the container and the sidecar, or is that a transaction which is going to be just an API response which comes back as a one-time action?
So it will be just a API response. So
Okay.
um,
So that could
so
be a
how
shared
this
public.
application might, yeah, that's a shared one. That's so
Mhm.
so that's why GPT is running somewhere else. Like there is no way
Mhm.
we can run GPT, like a large language model, in
In our
the
system, of
sidecar
course. Yeah.
in our system. Yeah, that's one. So here what we are essentially doing is, like, we're just kind of throttling our request uh, to the GPT API by doing some kind of a batching. So if you
Mhm.
see, it's in the pure sense, it's just sending batch requests to our GPT API instead of sending one request at a time. And
That
but
is a
how we are
great
batching
summary.
is,
Yeah.
we are batching it semantically. So we are using
Mhm.
Phi 3 to semantically batch our chat, like all the chat queries, and sending it to the GPT API.
Got
So
it.
you
Yeah.
can
That's a great
draw a
summary. Yeah.
parallel to a parallel to a generic non AI native system. So let's see how we can further optimize this. So we know that caching in these type of server side caching in these type of systems has a lot of benefits. Like it increases throughput, low latency, um, reduces the network calls and everything. But there is a problem in implementing caching in our system. See, I'll give you an example why it's difficult. So see, there are two, let's take these two strings, these two queries. How do I reset my password? And I need to reset my password. They mean the same thing, but their response is going to be the same. But the problem with conventional caching is that I need uh, a constant key, consistent key between these. So I won't be able to map how do I reset my password, and I need to reset my password to the same key. In conventional caching, we have a key and a response, and key is the request, and response, we store the response against that request, and this request response pairs are saved in the cache. So that type of caching will not work here, but we can figure out. So we can think of using semantic cache. So what is semantic cache? So in semantic cache, what we are doing is, in purest form, like in the simple terms, we are just trying to map how do I reset my password, and I need to reset my password to same response. Like we are trying to map them to a same key, but not exactly the key. But let's see how this works. So when we use LLMs or GPT APIs, uh, every every prompt is converted to a vector, and that vector is and then a completion is given against that vector in the again a form of completion vector. So everything is a vector. Like to the end user, these vectors are transformed back and forth to strings, like to natural language. But for system, for our GPT APIs and LLM, all these are vectors, uh, specifically called embeddings. So what we can do is, like, every user query that comes to us, we can save the uh, prompt and completion embeddings in a vector database. So every time when a new query comes in, we can create the embedding, we can create the vector and do a similarity search in our vector database before going to the GPT API. And in that similarity search, if we see that there is a similar query which we have already seen with that particular whatever threshold we have set for the similarity score, we can just use the response from the vector database, whatever we have cached, and return to the user, and we don't need to call the GPT API. So here, how do I reset my password? And I need to reset my password. They will have a very high similarity score, and whatever threshold we have set, if that matches, then we can use it from the vector database. So for this, we would need uh, a vector database solution. So there are tons of vector database solutions out there right now, like Qdrant, Pinecone, even Redis has started supporting it, PG vectors, a lot of database. So today we'll talk about Qdrant specifically. So let's see how our solution now optimizes with Qdrant, like how we are able to use. So now what we'll do is we are already running a Phi sidecar with the main container. Now we'll start running a Qdrant sidecar as well alongside with it. So every time I want to talk to the GPT API, my chat application will first talk to the Qdrant sidecar. Like this is the prompt, vector, and do a similarity search. If I already have if there is a matching, if I get a similar prompt and completion in my vector database, I can return it to the user. So this will further reduce latency and the cost, because we are now significantly calling the ChatGPT API significantly less times, like, because these queries are they are going to be repetitive, right? There is an issue. Multiple users are going to reach out to our chat application and with almost the same queries, and they'll be semantically same. So again, let's bring out that stateless pattern. So this Qdrant sidecar, again, it will run in each of those instances, and it is managing the state, but the state is not shared. So the state is that this Qdrant sidecar is storing the prompt and completion pairs in the memory, like in some kind of a cache. But this is not a shared state between the multiple instances. So each instance can have these shared instances, can have these states, independent states. So that's why Qdrant sidecar will be a good fit in our sidecar pattern. If it was some kind of a shared state between each of these Qdrant sidecars, then sidecar pattern may not be the best solution.
Got it.
So it is possible that a request that comes to an instance, there is a semantic cache hit, but on a different instance that is a cache miss. But that's fine. Like this is supposed to be a cache. So whenever there is a cache miss, it will store in the cache, and next time it will be a cache hit. So this is a trade-off. We can.
My question was on that actually. My question was on next time. Can you define when is the next time? Like, can you define when can we bring the states for all the instances together? Or is there like a specific fixed cycle when we do have all these vector databases at the same state for the next time?
So there is a trade-off. Like we can sync the states between all these Qdrant sidecars or all these caches, but we can't use a sidecar pattern. But if we have a very small size of cache that we want to use, if there are queries which are highly repetitive from the users, then each of these sidecars, Qdrant sidecars, can have their own state, and we don't have to worry about the syncing between them, because over time they will because they are serving almost same traffic, with time they will be in sync. Like they will have the same query and response, query prompt and responses stored.
Got it. So these instances that we create for web apps, Shubham, is that something which is basically acting as a load balancer on a randomized fashion, or is that going to be like, for example, one instance runs for Asia, one instance run for US? Is that like a region specific thing? How does it work? Is it random?
So so all these instances will run in one region where
Hmm.
your web application is hosted, and all these
Hmm.
instances will be behind a load balancer, and the load balancer will be sending requests in round
Randomized.
robin fashion. Yeah,
Okay,
in the
got it,
randomized.
got it. That
And
makes
in
sense.
some
Then I think,
instances,
yeah,
some
eventually,
yeah,
yeah, eventually the states
if the
will
cache size
get
is
there.
huge, then sidecar pattern may not be the best option, because then there'll be a lot of instances which will have cache misses. But if this
Hmm.
cache is very small, like there are highly repetitive queries, then the cache will be small. Then you
Hmm.
can then you can have uh, this independent quadrant sidecars in each instance, and then the cache hits will increase.
Got it. Makes sense, yeah.
Okay, so let's see how we can in how we can build this in Azure App Service. So this is the basic create web app page. I'm sure a lot of we are very familiar with this page. We specify the subscription, resource group, name of the instance, like the name of the web application. We are going to work with containers now. We are not doing the code scenarios, and it's a Linux application. So we select the region, create a app service plan. Uh, I would be recommending at least a 4 GB memory for uh, for these type of scenarios. But since we are running Phi 3 plus Quadrant, at least with that scenario, I think uh, I would recommend going over 16 GB at least. So in this example, I took 4 GB, but 16 GB would perform better.
And is
So
this support very specific to Linux as of today, or do we also have it in
yes,
Windows?
it is specific to Linux as
Okay,
of today.
okay, okay.
And then we go to this container blade. Here, the sidecar support. This is the preview feature. This has to be enabled. This is the only way we can add multiple containers. And we select the image source, like Azure Container Registry. These are some example. We select the Contoso chat application, and we'll come to this Py3 and Quadrant, how we can add. But on this, when we're creating an application, we have to specify the main container first. So we specify the this Contoso chat as our main application, main container, and we specify the port. So this port is very important. This is the main container, so all the web traffic will be routed to this port.
Hmm.
So essentially, this becomes our ingress container also. So we do a review, and then we create our application. So now we have created our application, which has the main container right now. We don't have the sidecars added right now. So let's add that. To add sidecar, I will go to deployment center, and see, we can see our main container already here, which has the Contoso chat image, and it's running on the port 5000.
Hmm.
So to add a container, I'll go to this add blade, and now let's add the Phi3 sidecar first. So I'll add Phi3. It is from the container registry. I will take the image as Phi3, and I will specify this port where Phi3 process is running on 11434 specifically for this image. So this port is required here, even though this is not exposed to the outside traffic, but still, for completeness, we have to specify this port here as well.
Hmm.
So this way, the Phi3 sidecar is added. Now next we want to add the quadrant sidecar.
Quadrant one. Hmm.
Yeah. So I'll add another, and for quadrant again, exactly similar process. Uh, Quadrant Azure Container Registry. I select the quadrant image. specify the tag, and again the port where that quadrant process will be running on 6335. And this is important here for completeness, even though it's not
Hmm.
exposed. And this is how our 3 containers would be running. So now the interesting thing is that what application developers have to keep in mind is that their main app, all these containers should know how to talk to each other over localhost. So let's say main container wants to talk to the Phi3 container. Main container needs to know that the Phi3 process is running on 11434, even though it's
Hmm.
specified here, but still the platform will not tell the main container that you need to talk to 11434 for Phi3. That the main container should already know. So this could be configurable via app setting, or environment variable, or maybe hard coded in the main container itself. It doesn't matter, but it needs to know. Similarly for quadrant, and
Hmm.
similarly for any container which wants to talk. So remember I talked about initially that all these containers run in the same network host. So what that means
Hmm.
is uh, they have a common local host. That's why these containers are able to talk via these shared ports like 5000,
Hmm.
11434. All these,
Hmm.
all this network host is same.
Hmm.
We, in our scenario, we did not, uh, we didn't need any file system sharing. But let's say there was another case where uh, where the main container was writing some logs to a file, and that and that there was another container which was reading those logs and sending it to some server. In that case, we
Hmm.
would have to specify a shared volume also. So there are only 2 options here right now, so that these containers can interact. That's the network and the shared file system.
Yeah, I think like when you were creating the containers, I saw the volume mount option
Yeah,
also coming up during the. Okay,
yeah,
good.
this one, yes, this volume mouse.
Hmm. Good.
And the next is that we need to specify app settings. Like here we are calling the GPT API, so we need the open API key, the deployment name, and the endpoint name. And make sure to always use key vault when dealing with keys. That's the recommendation always. And yeah, that's the way you can deploy a AI native application on Sidecar.
Wow, that is fairly seamless. So the basically like the whole process can be done within 10 to 15 minutes tops. So we are
Right.
having the whole end to end together. And how what happens next? Like for example, I want to update my sidecar now. Suppose I want to retrain my Phi 3 model and give it some more cues to be able to handle. Do I have to discontinue the sidecar and then attach a new image for it, or will it automatically pick the latest image every time there is an update?
So you can do it multiple ways, but let's start with the easiest way. What you can do is this this Phi3 is a clickable link, right? You can click and
Hmm.
start editing it. So when you click, this blade will open, and you can update the new tag here. So let's say you retrained your Phi and you have published that image on a new tag, and this you can update this image tag here. So,
Okay.
and the application will pick it and recycle your application, and you will get a the latest Phi3 model that you have placed. And this would work for any containers. You can
Mm.
also register webhooks by going to the Azure Container Registry. You can register a webhook there. I can share documents for our viewers. You can share the documentation, but yeah, there is an advanced way where you can uh, register a webhook on the container registry on that image, and whenever that image is updated, that will trigger this application to restart.
Hmm. Yeah, that makes sense, right? Because these are live applications. You, of course, need to keep
Yeah,
updating and changing it to the
updating it.
latest tag. But if my latest image tag is also called latest, does the latest
Hmm.
not mean that it will always pick the last release that I have done, or do you still think I have to update it?
No, we'll have to register a webhook. So if let's say you are
Hmm.
publishing the image on the same tag latest,
Got it.
for that scenario, we need to register the webhook. So once that
Hmm.
webhook is registered, you can keep on publishing to the same tag, and that will uh, keep on updating the application. That webhook will only update it
Got it. Makes sense. And registering the webbook is currently not on the current
on the
page that
portal
we
right
are on.
now.
We have to
Yes.
do it on okay, okay. Is that something that
So
you're
it's
looking
not on the
forward to?
portal. Yeah, we for GA uh, we will be releasing that feature. But right now there's a custom way where you have to go to the container registry resource, and at that image you
Hmm.
have to specify that webhook. And to get that webhook,
Hmm.
you get that webhook from the documentation.
Got it. Oh, okay. So this has been fairly interesting. So Shubham, just a couple of back questions. So right now, what all do we have in the Sidecar portfolio which is already supported other than Phi and Quadrant? Like what all can the users try?
So users can try any solution that is out there in the market. They just need the image. Like they can go on Docker Hub or any other image repositories. All custom repositories are supported. They can select the image, and they can run it on the Azure App Service at Sidecar. So currently we only
Okay.
support uh, 5 sidecars as of now, but that we are when we hit GA, we will review that number. But yeah, they can uh, potentially run any type of sidecar, like namely Redis,
What are
Nginx.
what are the five we are supporting right now so that the users are aware?
We the we are supporting only 5 sidecars, as in only users can only add 5 containers as
Oh,
of
the
now.
total. Okay, 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 okay.
Total
So the sidecar which could be run is still anything and everything which is available
anything,
in the.
which
Okay, got it.
yeah.
Cool. This makes sense. This is interesting. And have we had any like early feedbacks from any of the customers who have already tried it? Is there like something which is really looking forward to, at least which we can expect the users to target for GA? That hey, once GA comes, like for example, five was one good number, right? Like in GA, maybe you will have more than five sidecars. Is there some other interesting feedback we got from customers which we would be hearing as a GA feature?
So yeah, definitely. So this feature was a long ask from customers. Like it's been, I think, couple of years that customers were asking for this feature, and we already had a Docker Compose way of running multiple containers, uh, but we did not GA that. But this is definitely going to GA. And what we are seeing right now is customers, the most popular sidecars as of now are Redis and Nginx. These are the two sidecars that customers mostly add. So
Hmm.
those two sidecars are huge hits. Um, and I'm expecting as more AI native applications run, we would see a lot of vector databases and like Quadrant and SLM models would start
Hmm.
picking up.
Yeah, got it. Makes sense. This is really interesting. So I think we have reached the end of the demo. And for the viewers who are there in the chat, we have also have shared a lot of interesting links, which is all the resources that you could be using for trying out the product. It'll also be added in the video description. So with that, Shubham, I think if you have any concluding lines, anything that you would like to share with the rest of the audience on what could they do next.
Yeah, I think we have put in a lot of effort for this feature, and I would request users, viewers to go and try this feature, share as much as feedback through various channels, and so that we can iterate over it, build better features, improve it, and yeah, that's
That is really awesome. And Shubham, if people want to reach out to you to like ask questions or they want to contact you for getting more updates, how would you be reachable? Like, would you have some social media platform which you're active on?
yeah. I think LinkedIn is way to reach me. I think I'm active on LinkedIn, so yeah.
Okay, this is really good. Thank you so much, Shubham, once again for taking your time and helping us through this wonderful journey. I'm really looking forward to the GA. I'm hoping that it is going to be a very big blast for app services and all your hard work is going to come in a beautiful way. So, once again, thank you all the viewers who have been
Thank
through
you.
this journey with us and looking forward to meet you all again very soon. Happy weekend. Bye bye.
Bye. Thank you.